Hello. Today in this video lecture we will see numerical on Rankine's formula. So first read this numerical. First step is understanding numerical. Don't go blindly towards solving numerical. First understand it thoroughly. So see, find by Rankine's formula the same axial load. So problem statement is this. We have to find this same axial load which an angle strut of. So they have given us that angle strut 65 mm 65 mm by 8 mm. That means this is equal angle strut, and that length of the strut is 2 meter long, and boundary conditions are one end fixed and other end hinged, and factor of safety given us 3 for this area. For that same equal angle section, area is 976 mm square and minimum radius of gyration is 12.5 mm, and that this stress, crushing stress, and this alpha Rankine is constant. So see, 65 mm, this equal angle, that means this is also 65 mm, this is also 65 mm, that side of that angle. And now write this given data. Length is 2 meter, that means it is 2000 mm. Boundary conditions, one end fixed and other end hinged, that means like that. And deflection, buckling of that column is like this. This is effective length, and this is 2000 meter actual length, 2000 mm, not meter. This is 2000 mm actual length. So as per that, we will see this effective length for that one end fixed and other end hinge is nothing but the actual length divided by root 2. So actual length is 2000 divided by root 2. So that means it is 1414.21 mm. Factor of safety is 3. Area 976 mm square. Minimum radius of gyration, that means K minimum is equal to 12.5 mm, and that is crushing stress is 320 MPa. That alpha Rankine constant 1/7500. So we know that Rankine's formula. What is Rankine's formula? PR is equal to sigma C area, sigma C into area divided by 1 plus alpha into effective length by radius of gyration square. So this sigma C is nothing but the crushing stress, area is nothing but that equal angle area, alpha is Rankine constant, Le is effective length. Effective length is nothing but the distance between point of contrapictures, and we learned that point of contrapicture, it is that where that bending moment changes sign, and k is that radius of gyration under root of moment of inertia upon area. So we have all of these values, so just put these values in this equation and solve this numerical. So sigma c is 320 MPa. Area is 976 mm square. One plus alpha is 1 upon 7500. See here, multiply sign. Observe this formula. Early we had calculated that L by root 2, as per boundary conditions, 1 in fixed, 1 in hinge, that means L by root 2, and L is 2000 divided by root 2, that means 1414.21. K is given quantity, so this K 12.5 mm. Okay, and square of it. So this PR is 320 into 976 divided by 1 plus 1 divided by 7500 into 1414.21 divided by 12.5, square of that. So solve. It is 115389.52. Unit is Newton, and in kilonewton it is 115.389 kilonewton. So that is that as per Rankine's formula, buckling load, or you can call it like a crippling load, buckling load. So our problem statement is safe axial load, and they have given us that factor of safety is 3. So safe axial load is nothing but that buckling load divided by factor of safety. So buckling load is 115.389 divided by factor of safety 3. So that safe load is 115.389 divided by 3. It is 38.463 kilonewton. So this is our objective, and it has completed. So this way our numerical completes. Thank you very much.